You see, it's from the dimension part. So that really indicates that this chapter of units and measurement has to be taken very seriously. This question is again a very straightforward one. Momentum, area and time are taken to be the fundamental. We need to calculate the dimensional formula for energy. This one goes in a very straightforward way. The energy is momentum per unit time. That's going to give me force, all right, and distance part. So the distance part has to be root A. So that goes in a faster way if you want to get that. So this gives me which answer? Option number 3. That will be the dimensional formula for energy. And now let's go for the next, the 8th question. This is related to simple harmonic motion here. You could see the displacement versus time that's been given and the period has been marked. The segments have been given there. We need to see the correct options. Again, we need to scan out one by one. Force is 0 at t equals to 3t by 4. This is correct. Why so? Because at 3t by 4, the displacement is 0. The particle is at the mean position. That means the force has to be 0. The second case, acceleration is maximum at t equals to capital T. That's again correct. Because at this time, the particle is at extreme, at the amplitude. So the acceleration has to be maximum. Number C, the speed is maximum at t by 4. That's again correct because this is the mean position. So speed will be maximum. And the potential energy is equal to kinetic energy of oscillation at t equals to capital T by 2. That is incorrect because at capital T by 2, half of the time period, the particle is at negative extreme. And here the kinetic energy is 0 while the potential energy is maximum. So in that regard, you could say option number 4 is incorrect. And now let's try to see where do we get A, B, C correct. The correct option will be option number 3. Let's go further to question number 9. Question number 9 is from moving charges and magnetism, wherein we need to see the path of a charged particle in a magnetic field. Look at the question and let's see what does it say. There is a certain region of length L with a uniform magnetic field. So that means the magnetic field B is given. Let me pick out the variable. That would be a better way. At the end, we may plug in the value. The velocity is also given. That's V. And even the angle, 60 degree, is there. Now, what would be the path? Of course, that's going to be helix because the angle between velocity and magnetic field is 60 degree. Further, let's see. This particular proton, the charged particle, completes 10 revolutions by the time it crosses this region of length L. And we need to find the value of length L. Now, let's break down the whole numerical into 2 steps. And that's something like this. If I resolve the velocity, say there is one velocity in this direction and there is another velocity in this direction. And this particular velocity, this is of course v by 2 and this velocity is root 3 v by 2. Root 3 v by 2 is going to give the circular path and this v by 2 is going to advance it forward, ultimately giving the pitch of the helix. Now let's see how much would be one pitch. That's of course v by 2 into 2 pi m by bq. So that's the distance covered in one revolution. But the question says by the time it crosses this segment, it would have made 10 revolutions. So we need to multiply by 10. That will give the forward distance and that can be equated to L. So that's now a little bit of calculation. Option number 4 would be correct. Let's go to question number 10.